1.910 rational functions, vertical asymptotes, and holes. Yamil's going to read for us. Let's do this.
Recall, a rational function is the quotient of two polynomials. Rational function y equals f of x over g of x, where f of x and g of x are both polynomials. Since we're dividing by a polynomial, rational functions have restrictions on their domain. We know that we cannot divide by 0, so we must consider any x values where g of x equals 0 and restrict them from the domain. These x values will be the location of either a vertical asymptote or a hole in the graph. Vertical asymptotes and holes both occur when the denominator of a rational function equals 0. So how can we distinguish between these two when working with a rational equation?
I don't know, we just guess. All right, just kidding. That's not how we do it. All right, but both of those are when my denominator is equal to what? 0. All right, and so here we go. Vertical asymptotes and holes. A hole occurs when the factor in the denominator cancels out with the factors in the numerator. I like to say it's when your x value gives you a 0 over 0. That's what creates a hole. A hole is when you get a 0 over 0. Something has to cancel out in that. So if you look at Bree's board point, what canceled in Bree's board point? The x plus 4. But what x value made that happen?
4. -4.
-4. So -4 is going to have a hole there. All right? Something had to cancel. You had to get that 0 over 0 that happened, and that's going to create a hole. All right? Let's keep going. So a vertical asymptote is when I have factors in my denominator that cannot cancel out with its numerator. So this is what I like to say is when you get a number over 0. I don't care what number it is. But if you get a number in the numerator and you get a 0 in the denominator, you're going to have a vertical asymptote. So for instance, I guess Bree didn't factor that one out, but like it was, I think it was 2x minus 1. Yeah, 2x minus 1. And so if you had 2x minus 1 in this factor, then you have x equals 1/2 is my vertical asymptote. Because I'm going to have a number up top and I'm going to have a 0 in the denominator, and that's what creates that vertical asymptote. All right, so what's a hole? How do you get a hole?
0.
How do you get a vertical asymptote? Number over 0. I'm going to say that a lot these next few days. All right, so let's look at these examples. Some are pretty simple, some are pretty easy, or some are pretty hard. So if we have x minus 1 and then x plus 2 and then x minus 1, what's going to cancel on this one?
X minus 1.
The x minus 1's cancel. And so when you cancel it, it creates the hole. It creates a hole. And what x value did it create a hole at? At 1. All right, it created a hole at 1. And so we'll talk about substituting in the simpler function in just a sec. But if you look at this next example, I have x minus 1 cubed over 2 times x minus 1 squared. And so what canceled again?
X minus 1.
X minus 1 what? Squared. And so this squared goes away, and then this 3 actually goes to a power of what? 1. All right? And so this one goes away. So do I have anything left on the denominator? 2, yes, okay. But like any x's? No. And so when I substitute in 1 now, will I get a 0 in the denominator? In my simpler function, will I get a 0 in my denominator? No. All right, I won't. Okay, so I won't have a 0 in my denominator anymore. So that's why it just creates a hole. All right, and so anyway, if I do a simpler function here, do you see how x minus 1's canceled in my first one? Do you see how x minus 1's canceled in my first? So I'm left with this x plus 2. Does everybody see that? And so if I were to substitute in 1 in this what's called a simpler function, 1 plus 2 is equal to what? 3. And that's where my limit is. And so when I substitute in 1, I get 3 into what my simpler function. So this is where my hole is. So my hole will be at 1, 3. And we'll do it again. All right? But how do you get a hole? You get what? 0 over 0. Something has to cancel out in that case. All right, so let's talk about vertical asymptote. So what's the thing I want you to think of vertical asymptote? A number over 0. And so let's look at this equation on my first one. And so what value of x will give me a number over 0 in this first one? 1. So x equals 1 is my vertical asymptote because I'm going to get some kind of number up top. All right, I'm going to get, what is that? 1 minus 3, so we get negative 2, and then times 3, so we get negative 6, right? But I don't really care. It's a number over what? 0. And so a number over 0 will create that vertical asymptote going on. Let's looky here. This is where this one gets really kind of weird, all right, and slightly confusing. So I want you to focus in on this one. What happens on this one? What cancels? X minus 1's cancel, right? And so this one cancels all the way out, but then this one has a degree of 1 now because I canceled one of them out. Does everybody see how that happened? And so instantly you're like, hey, I canceled something out. It creates a hole. And part of me says, like, go with it for right now. Go with it saying it's a hole. However, if I were to substitute in 1 on this one, I'm going to get 3 over what? 0. And what did that create? A vertical asymptote. And so if I have a hole and a vertical asymptote, the vertical asymptote is going to win every time. Okay? Because you can't have both. It's going to be a vertical asymptote on that one. So the way that I like to think about it is if it doesn't cancel on my denominator, it's going to be a vertical asymptote because that kind of like overpowers it. That's kind of how I think about it. All right? And so this one's still going to have a vertical asymptote at 1. All right? And I'm going to talk about positive and negative infinities in a sec. All right? All right, let's keep moving. So here we go. So we're going to determine any x values of any holes or vertical asymptotes. All right? So on part A, do I have any holes?
X plus 3.
Yeah. So where's my hole at?
-3.
At negative 3. Does everybody agree with that? Okay, when I substitute a negative 3, these things are going to cancel out and give me 0 over 0. Agreed? All right, so I have a hole at x equals negative 3. I'm going to go further, though. I want to actually find the y value. Okay, so I'm going to kind of go a little further than what this note's saying to do. And so the way we do it is I have this simpler function of x minus 2 over x minus 5. So all we're going to do is we're going to substitute in negative 3 in right here. And so I now have negative 3 and then minus 2, which is what? And then I have negative 3 minus 5, which is what? So I have negative, what was it? 5 over negative 8, which is 5/8. So I actually will have a hole at this graph of negative 3 comma 5/8. Pretty good? All right, so do I have any vertical asymptotes going on? Yes. When? What x value? X equals 5. All right? Because I'll get a number over 0 there. All right? Well, my number will be 3 over 0. I don't really care what number it is, but it will be a number over 0. And so that's where my vertical asymptote is. Pretty good? Cool. Let's keep moving. All right. So let's look at this one. Can I cancel out anything on this one? This one's kind of a funky one. I really want you to focus in on this one. What can I cancel out?
X plus 1 and x minus 2.
Okay, we can cancel out both of them, can't we?
Yep.
That's weird. So let's do what do you want to do? X plus 1 first?
Yep.
All right, let's cancel out an x plus 1. So that one goes away, and then this one goes to a degree of what? 1. So is that a hole or is that a vertical asymptote? That's a vertical asymptote. Why is this one a vertical asymptote? Because where does it go to 0 at? In the denominator. All right? And so now my vertical asymptote would actually be x equals negative 1. Now, what else can I cancel out? The x minus 2's. So that one goes away in the denominator, but then it will still have something in the numerator. All right? And so that did cancel out, true? And so that creates a what? A hole. And x equals 2. Now, I want to go further. All right? I want to figure out what the y value is. And so when I substitute in 2 into my simpler function of x minus 2 over x plus 1, what do I get? 2 minus 2 is 0 over 3. Can we do 0 over 3? Yeah. 0 over 3 is what? 0. All right, so I have a hole going on at 2 comma 0. Now, the reason why this is a vertical asymptote again is if I were to substitute in -1, I'd get -3 over 0. What did we just create on a -3 over 0 thing? We get a number over 0, and that makes a vertical asymptote. All right, this one's a complex one, and hopefully we got that one. All right, on part C, what do we get to do? Factor it. Let's factor it. Let's do it. All right, so what's it f up to?
Let's do x squared. No. Oh, no, x. Okay, so x and then parentheses x squared plus 2. Oh, yeah, plus 4.
First try. All right, and so can we factor x squared plus 4 anymore? So does this one have any holes? Did anything cancel out? No. Does it have any vertical asymptotes? Will I ever get a number over 0 with any x values? Yes. Yes. Can I set this part equal to 0? Yeah. What do I get? I get 0. So I get a vertical asymptote at x equals 0. All right. Before I do this next section, I want to freestyle a concept with you. When I have a vertical asymptote, it either starts going up, or it goes down, or both of them go down, or both of them go up. All right? Does everybody kind of agree with me on that statement? Does everybody agree with that? You know this is happening. Okay. All right. On this example, we're going to find the left and the right-hand limit statements as x approaches 2. All right, so this is new notation for you. All right, so please focus in. So I'm going to find a limit as x approaches 2 from this little negative sign. And the way we read that is it's from the left. All right, it's a little superscript of a negative. All right, because it means it's a little less than. If you understand your number line, okay, like if we understand our little number line going on, left of 2 is like a little bit less than 2. It's negative. It's less than. All right, if you're like subtracting. All right, and so then my right hand is going to be a limit as x approaches 2 from the right, and so it's a little bit more positive now of 2. All right, and so there's our notation for how this works. And so at an asymptote, it's either going to go to infinity, it's going to go up, or it's going to go down. Like, those are my only two choices. All right? Now, let's looky here. So if I have x minus 1 times x plus 3 over x minus 2, what is x equals 2?
Say it again.
What is x equals 2 give us? Does it give me a hole at 2 or a vertical asymptote? It gives me a vertical asymptote. Why? It's a number over 0. Does everybody follow me? So I now have two choices. As it approaches from the left, it's either going to go to infinity or it's going to go down to negative infinity. Does that make sense? Because it's a vertical asymptote, those are my only two choices it's going to be. Does everybody agree? All right, so this one from the left, I need to think of it as like just left of 2. So it's like 1.999. You follow me? 1.99999. Got it? So if I substitute in 1.999 right here, is this positive or negative? Positive. Is this positive or negative? Positive. This is going to be a really small what? Negative. So I have any positive number that I really care about over a really small negative. So what do you think it goes to? Negative infinity. And the way that you can kind of think of it, let's say I have the number 3. If I take the number 3 and I divide it by negative 0.000000000000001, that's going to be a really big negative. Are you following me? And so that's what it's really doing right there. All right, so as it approaches from the left, it is going down to negative infinity. All right, let's do it from the right now. And so my limit as x approaches 2 from the right. So if I substitute in 2 here, I'm going to get a what? How about here? So I still have a positive in my numerator. Now, when I do 2 from the right, I think of like 2.01. And so now this is going to be a really small what on the denominator? Positive. So I have a positive over a really small positive. So what does that become? Positive infinity. Cool. Let's do it again. So let's look at part B. So we're doing, as x approaches 2 from the left and 2 from the right, so let's get in our habit of doing our left and right, even though at a whole this doesn't really make sense to do, but let's do it. So I do a limit as x approaches 2 from the left, so that's why I have a little negative thing. And then I'm going to do a limit as x approaches 2 from the right, so I got my little plus sign going on. All right, what happens at 2? Is it a whole or is it a vertical asymptote? It's a whole. Why is it a whole? I get 0 over 0. So what should I do with this x minus 2 thing? It cancels, right? And so when it cancels, it gives me this x plus 4 over x minus 3 because this is my simpler function. And so we don't need to go a little bit left and a little bit right. That's when we get a vertical asymptote. So I'm just going to substitute in 2. So 2 plus 4 is 6 over negative 1. So I have 6 over negative 1, which is what? Negative 6. And guess what 2 from the right is still going to be? Negative 6. All right? Because at a whole, we don't need to go a little bit left and a little bit right. It's just going to be a whole there. We just substituted in my simpler function. All right, let's look at this next one. What happens at 2? First of all, let's write our limit statements. So we have a limit as x approaches 2 from the left. So now we have a little negative sign. Oh, I called this f of x. Shame on me. This should have been a g of x. You should have yelled at me. This needs to be an h of x. All right. And then I do a limit as x approaches 2 from the right of h of x as well. All right. So what happens at 2? Does anything cancel?
Yes.
Yeah, it cancels, right? So x minus 2's cancel, but where's x minus 2 still located? In my denominator. What's happening at x equals 2? It's a vertical asymptote. Even though it canceled, it's still a what? A vertical asymptote. Okay? Because if I substitute in 2, I get negative 2 over 0. Does everybody follow me on this? And so it's still going to be a vertical asymptote. So now I either have infinity or negative infinity as my answer choices. All right? So let's do it from the left. So how do I think of 2 from the left? 1.99, right? And so then what do I have up top? Negative 2-ish, right? Negative 2. And then over what? 1.99 minus 2? We got a really small what? Negative. And this is going to be a what? A positive. So I have a negative over a really small negative, which is going to be what? Positive infinity. All right, let's do it 2 from the right now. So how should I think of 2 from the right? 2.01, right? And so now, if I substitute in 2.01, what do I have up top? A negative over a really small what? Positive times a positive, so it's still a really small positive. So I have a negative over a really small positive, which is what? Negative infinity. All right. And so the way we read that is when we approach from the left of 2, it goes up. When we approach from the right of 2, it goes down. All right, that's really what's happening. All right.